In this session, we are going to discuss about the polymers. Already we are having the number of polymers such as polyvinyl chloride, polystyrene, and polyethylene. Each one is having the number of applications. For example, the plastic pipe we are using, and the polyethylene cover we are using, and finally, the TV cabinets we are using are purely made up of polymers. So, without the polymer, there is no human being. So human being life is completely associating with the use of the polymers. Now this topic is very interesting for Cbse class 12, and these are the basics for the organic chemistry. Coming to the definition of the polymers are the large molecules which are formed by the linkage of a small number of monomeric units. Okay, this is the definition of the polymers. So before we are going to understand the definition of the polymers, first of all we should know about the monomeric units. Monomers are nothing but repeating units. So without using the monomer, there is no formation of the polymer. In this session, we are going to discuss about the introduction to the polymers as well as the classification of the polymers. The best examples of polymers are polyvinyl chloride, polystyrene, as well as polyethylene. And when we observe the three words polymers, every word is starting with the poly. So poly is not the Indian word, poly is the Greek word. According to Greeks, poly is called as many. So many number of vinyl chloride monomers will be combined to produce the polyvinyl chloride, and many number of styrene monomers will be combined to produce the polystyrene, and many number of ethylene monomers will be combined to produce the polyethylene. Okay, this is the definition of the polymer as well as examples of the polymers. Next one, we should know about the polymerization process. Now what is the polymerization process? Now there is the process of converting the monomer into the polymer, which is called as a polymerization process. So every monomer is converted into the polymer by the number of the process. That kind of the process is called as a polymerization process. Now there is the example. So in this example, we have observed the presence of the monomer, which is called as ethylene, and finally this ethylene is converted into the polyethylene. We are having two types of polymerization reactions. So these are the reactions which we are going to discuss later. Next one, we are going to discuss about the degree of polymerization, which is denoted by dP. So what is the meaning of degree of polymerization? Degree of polymerization is defined as the number of repeating units or the number of monomeric units which are present in the polymer, called as degree of polymerization process. Already each polymer is having a number of monomeric units, so that monomeric unit is also called as repeating units. All the polymers are not having the same number of repeating units. So depending upon the number of monomeric units which are present in the polymer, we are having the two types of the polymers. One is the oligopolymer and next one is the high polymers. So when we observe the oligopolymers, so oligopolymers are having a dP value which is completely having less than 600. So that means each polymer is having less than 600 number of monomeric units. So because of having the less number of monomeric units, these are the polymers which are not act as engineering materials. The best example of oligopolymer is nothing but polyethylene. And coming to the second one, high polymers. So coming to the high polymers, the polymers whose dP value is above 600, known as high polymers. So these are act as engineering materials because these are having above 600 monomeric units. When the number of monomeric units are more, which is present in the polymer, we can observe the force of the attraction between the number of the monomeric units. So that's why we can observe the strength of the polymer is more. And after the completion of degree of polymerization, then we are going to discuss about the functionality. Now what is the meaning of functionality? Functionality is nothing but a number of reactive sites or the number of bonding sites present in the monomer, which is called as functionality. So in the polymer, number of monomeric units will be joined by the number of the bonds or the number of attractive forces. That attractive forces is called as the bonds. Now the area or the site which the bond is attached to the monomer is called as reactive site or the bonding sites. We are having the number of the polymers all the polymers are not having the number of reactive sites or the bonding sites. So depending upon the number of reactive sites or the bonding sites, we have three kinds of the monomers. One is the bifunctional monomer, bi means two, so this polymer is having only two monomeric units. And the second one is the trifunctional polymer, which is having the monomeric units 3. And next one is the polyfunctional monomers, which are having the bonding sites 4. So this is about the functionality. Next one, classification of the polymers. So coming to the classification of the polymers, we are going to discuss about the homopolymer. So when we observe the homopolymer, the polymer is having the same type of the monomeric units known as homopolymer. Okay, this is the structure you are observing. In this structure, we have the polymer which is shown A. That means this polymer is having the same type of monomeric units, and also in between the number of the monomeric units, you can observe the presence of the bond. The bond may be weak or the bond may be strong. There is the presence of the bond compulsory. Now this kind of the polymer is called as homopolymer. So when we observe the structure of homopolymer, the homopolymer is having the same type of monomer, which is called as capital A. The best example of homopolymer is called as polyvinyl chloride. So when we observe the polyvinyl chloride, this is the polymer which is having the same number of monomeric unit, that is called as vinyl chloride. This vinyl chloride is repeating in a number of times. And coming to the heteropolymers, the polymer which is having the different types of the monomers, those are called as heteropolymers. So when we observe the structure of heteropolymer is having AB, etc. Now this is purely different from the homopolymers. So in these polymers, so we can observe the type A and also type B monomers here. So this polymer is having the different types of the monomers. So because of having the different types of the monomers, this polymer is called as heteropolymer. The best example of heteropolymer is called as SBR. In short form, in elaborated form, that is called as styrene butadiene rubber, which is act as the rubber for the preparation of the shoes as well as a number of footwears. Now this is about the homopolymers and the heteropolymers. Now as soon as the completion of homopolymers and heteropolymers, now we are going to discuss about the three types of the polymers, which is purely basing on the source and basing on the structure and basing on the intermolecular force of the attraction. First one is the basing on the source. So the basing on the source, the polymers are mainly classified into the two different types. One is the natural polymer and next one is the synthetic polymer, and the third variety is called as semi-synthetic polymers. And when we observe the natural polymers, these polymers which are completely produced from the nature itself, so those are called as natural polymers. The best example of natural polymers are called as proteins, wood as well as cellulose. So these are the polymers which are purely produced from the nature itself, so these are called as natural polymers. And coming to the synthetic polymers, the polymers which are produced by the synthetic process, which are called as synthetic process. Now the synthetic process is nothing but man-made process. So by using the synthetic process, we are able to produce the number of synthetic polymers such as polyvinyl chloride as well as polystyrene. These are not available in nature. These are completely produced by the synthetic process only. So these are called as synthetic polymers. And the third variety of the polymer is called as semi-synthetic polymers. So these are the polymers which are completely derived or which are completely produced from the natural polymers. So these are nothing but semi-synthetic polymers. Okay, this is the classification of the polymers, purely basing on the source. So simply a source is nothing but from where the polymers are produced, that is called as the source. Next one, the second classification of the polymer, that is purely basing on the structure. So basing on the structure, the polymers are classified into the different types. One is the linear polymers. So in the linear polymers, the monomers are arranged in the form of the straight line known as the linear polymers. So this is the structure you are observing in the linear polymer. So when we observe the structure of linear polymer, all the monomers are completely joined together by attractive force, which is known as the bond. Linear polymers are having the strong intermolecular force of attraction between the number of the monomeric units. That kind of the bond is called as covalent bond. So because of having the covalent bond, linear polymers are having a high melting point as well as high strength and high density. Melting point is nothing but the temperature at which the solid polymer is converted into the liquid, which is called as melting point. Now the second kind of polymer is called as branched chain polymer. So the branched chain polymers are completely produced from the linear polymers. So the linear polymers are completely produced, and from the linear polymers there are number of branches are arising. So this kind of the polymers are called as branched chain polymers. Now this is the diagram which is act as a branched chain polymers. In this diagram you can observe the number of the branches which are completely arising from the linear polymer. Now coming to the strength of branched chain polymer, the strength of branched chain polymer is very less as compared to the linear polymers. So because of having the weak intermolecular force of attraction, so these are the polymers which are having the low strength and also low density and also low melting point. LDPE, LLDPE as well as HDPE, which are produced by using the branched chain polymer itself. The next classification basing on the intermolecular force of attraction. Each monomer which is present in the polymer is held by intermolecular force of the attraction here. Now the intermolecular force of attraction is not same in all kinds of the polymers. So basing on the intermolecular force of the attraction between the number of monomeric units, we have 4 different types of the polymers. One is the thermosetting polymer, and next one is the thermoplastic polymer, and next one is the rubbers or elastomers, and finally fibers. Now each polymer is having the specialized character. So coming to the thermosetting polymers, now the polymers which undergo the permanent change, which are on heating, known as thermosetting polymers. So when we heat this kind of the polymers, this polymer is converted into the permanent change. So further the application of high temperature as well as high pressure to the polymer, then we can't observe any kind of the change. Okay, this is the meaning of thermosetting polymers. Now there is the reason why the polymers are having high strength and why the polymers do not exhibit the permanent change. So because when we observe the thermosetting polymer, each thermosetting polymer is completely having the number of monomeric units. In between the number of monomeric units there is the presence of attractive force which is completely strong, which is called as a covalent bond. Covalent bond is having high strength as well as high density. So because of having this kind of specialized character, thermosetting polymers do not converted into the liquid by the application of heat or by the application of high pressure. So when we apply more and more temperature to the thermosetting polymer, this polymer is readily converted into the ash. So that's why these are the polymers which are not converted into the liquid very easy. The best example of thermosetting polymers are nothing but bakelite, phenol formaldehyde resin. These are the best examples of thermosetting polymer. And the second kind of the polymer is called as thermoplastic polymers. Now these are the polymers which are quite opposite to the thermosetting polymers. So thermoplastic polymers are the polymers which are converted into the liquid, so by the application of high temperature as well as high pressure. So simply these are the polymers which are converted into the liquid by the application of high temperature, and these are the polymers which are converted into the solid by the application of low temperature itself. So the main reason is nothing but thermoplastic polymers are having the weak intermolecular forces between the number of monomeric units. So because of having the weak intermolecular forces between the monomeric units, by the application of high temperature, the bonds between the monomers completely broken into the number of the pieces, and finally all the monomers are completely separated and all the monomers are converted into the liquids very easily. So these are called as thermoplastic polymers. Now the strength of thermoplastic polymers are completely very low as compared to the thermosetting polymers, because of having the weak intermolecular force of attraction. And there is the one more character of thermoplastic polymer. So after the conversion of solid into the liquid by the application of cooling or the low temperature, the liquid polymer is converted into the solid again. So these are called as thermoplastic polymers. Now the best example of thermoplastic polymers are polyvinyl chloride or PVC, which is completely used in the preparation of plastic pipes. So thermoplastic polymers are easily molded And the third variety of the polymer is called as rubbers and elastomers. Rubbers and elastomers are having the intermediate force of attractions between the thermosetting polymers as well as thermoplastic polymers. So by the application of high pressure, these polymers are undergo stretching, and by the application of stress, and these are the polymers which are completely return to its starting position. So this kind of polymers are called as rubbers or elastomers. The main reason is nothing but these are having the intermolecular force of attraction between the thermosettings and thermoplastics, that is very intermediate compounds which are completely covalent bonding as well as weak bonding. The best example of rubbers or elastomers is nothing but a natural rubber. And the fourth variety of the polymer is called as fibers. Now as compared to the thermosetting polymers, thermoplastic polymers and rubbers and elastomers, the fibers are having more strength because of having the strong hydrogen bonding in between them. So these are the polymers which are having the covalent bond itself. So along with the covalent bond, there is the presence of hydrogen bonding. So these are the polymers which are having high strength. The best example is nylon 6 and 6. Now this is the polymer which is purely used to prepare the plastic plates as well as fiber plates at our home. Okay, this is the classification of the polymers basing on the source and basing on the structure and basing on the intermolecular force of attraction. Now coming to the order of strength of the polymers, fibers are having more strength, and after the fibers, thermosetting polymers are having high strength, and after thermosetting polymers, thermoplastics are having high strength. The last rubbers are having high strength. Okay, this is the order of the strength according to the intermolecular force of the attraction. If you read NCERT completely, you can get the complete information. Now this topic is very useful for the students which are going to write the competitive examinations. Now in the next session we are going to discuss about the types of polymerization.